In this video, all individuals shown making the electrical measurements are wearing personal protective equipment consistent with the standards established for the United States by the National Fire Protection Association, or NFPA. NFPA Electrical Safety Standard 70E sets categories of hazard and risk from 0 up to 4. As the work environment and the type of job become more hazardous, the need for protection increases. For example, work on a 600-volt motor control center would require varying levels of protection, depending on the job. Operating a circuit breaker with enclosure doors closed is hazard risk category 0. Required personal protective equipment, or PPE, includes a long-sleeve shirt and long trousers made of natural fiber material, and safety glasses. Performing the same operation with the panel open increases the hazard risk level to 1. Here, you need to add a long-sleeved, fire-resistant shirt and heavy cotton pants, such as blue jeans, fire-resistant trousers, or fire-resistant coveralls. You may also need leather gloves and leather work shoes. Voltage testing on energized parts increases the risk hazard level to 2+. For this job, you need a natural fiber t-shirt under your fire-resistant shirt and natural fiber trousers under your fire-resistant pants or coveralls. You need safety glasses or safety goggles under a double-layer switching hood, and earplugs. Voltage-rated leather gloves and tools are also required. Insertion or removal of individual starter buckets from the motor control center takes the hazard to level 3. For this job, you must add a hard hat with fire-resistant liner, switching hood, earplugs, voltage-rated gloves, and work shoes. As you can see, as the risk of your job increases, the protection required by NFPA also increases. For details on all NFPA requirements, read the NFPA 70E manual carefully. When you make electrical measurements, safety should always be your first consideration. If you plan your work carefully, follow safe measurement procedures, and use the right equipment, you can cut your chances of an accident to near 0. Your first step is planning. Before you open an equipment cabinet, look over your work environment. Where will you mount your meter and place your other equipment? Be sure to identify a clear escape route you can use in case of emergency. Do you have enough clearance to gain access to the equipment in question and to work comfortably? Are environmental hazards present, such as tree branches or water? Do you have enough light and ventilation? Make sure you have a qualified helper on hand who also understands electrical safety. It's never good practice to work alone on high-energy circuits. Finally, make sure someone else knows where you're working. Another key part of planning is choosing your safety equipment, tools, and assistance. Make sure you have the required personal protective equipment, or PPE, on hand: eye and hearing protection, gloves, clothing, and insulating mats. Be sure to inspect your equipment to make sure it's in good condition. Check your tools for proper insulation, and make sure your meters and testers are rated and tested for the level of hazard that exists where you're working. Many testers look similar, but make sure you know what yours is designed to do. Then, inspect your meters, testers, test leads, and related equipment to make sure everything is intact and working properly. At the end of this video, we'll show you how to test your meter and test leads. Whenever possible, work on de-energized circuits and always follow proper lockout-tagout procedures. When taking single-phase measurements, always connect the grounded lead first, the hot lead second. After taking your reading, disconnect the hot lead first, the grounded lead second. To make sure your meter is working, use the 3-step test method. First, test a circuit you know is live. Next, measure the target circuit. But before you conclude that circuit 2 is dead, retest the known live circuit. This way, you know your meter is working. Try to follow the old electrician's advice. Whenever you can, keep one hand in your pocket, but use common sense. Sometimes you need both hands to make a good measurement. The safest place to measure voltage is where the lowest energy is available. For example, if you're measuring voltage on a breaker panel, identify the lowest rated breaker available and make your measurement there. This way, you have more protection between yourself and the potential hazard. Following these steps will help you work safely. But sometimes, even these steps can't prevent trouble. Switching of inductive loads, lightning strikes, and transmission system switching can generate huge voltage spikes. These voltage spikes, or transients, can last as long as 100 microseconds, but they can be extremely dangerous. In modern power systems, transients are present all the time, some small and some large. But where do transients come from? When an inductive load such as a motor or transformer is switched off, it generates a voltage spike, sometimes called a kickback spike. In some applications, kickback spikes are useful. Your car's ignition system depends on kickback spikes generated by the coil to produce a spark. But when we're measuring power systems, transients and sparks are definitely not good. And here's why. In your car's ignition, the power source is weak and the spark disappears as soon as the voltage does. But in a power system, the system voltage does not disappear, and because the circuit is a high energy source, it can supply current to the spark until the surrounding air breaks down into a conductive plasma, causing a major fault. When transients ride on top of the system voltages that supply industrial loads, they can reach thousands of volts, and the consequences can be devastating, particularly for anyone taking measurements on electrical equipment. In these circumstances, proper procedures alone are not enough. You need to reduce risks by using the right meters and test equipment, tools rated for the environment where you're working, and tested to meet the appropriate safety standards. To provide better protection for electrical workers, new standards have been developed for test equipment used in environments of 1,000 volts or less, including 480 volt and 600 volt three-phase circuits. In the four-category rating system, the closer you are to the power source, the higher the category, and the greater the danger. Transients in categories, or CATs 3 and 4, can be extremely dangerous. The available fault current in these high-energy circuits can reach as much as 100,000 amps. CAT 4 refers to power lines at the utility connection, but it also includes exterior overhead and underground cable runs, since both may be affected by lightning. CAT 3 covers distribution level wiring. This includes 480 or 600 volt circuits, such as three-phase bus and feeder circuits, motor control centers, load centers, and distribution panels. Permanently installed loads are also CAT 3. CAT 3 also includes big loads that can generate their own transients and are now more common than many people realize. The trend to using higher voltage levels in modern buildings has changed the picture and increased the potential hazards. Most commercial and industrial electricians work on equipment in a CAT 3 or CAT 4 environment. Many times, people may be working in a CAT 4 environment without even knowing it, and that can lead to real danger. Lower category installations usually have greater impedance, which dampens transients and helps limit the fault current that can feed an arc. CAT 2 covers the receptacle circuit level and 120 volt plug-in loads. And CAT 1 refers to protected electronic circuits. Some installed equipment may include multiple categories. This motor drive panel is CAT 3 on the 480 volt power side and CAT 1 on the control side. In these environments, you should use the higher rated CAT 3 meter. Remember, in general, where greater fault currents are available and as voltage transients increase, measurement becomes more hazardous. This is reflected by a higher CAT rating. National standards for workplace safety include test instruments as part of personal protective equipment. The National Fire Protection Association clearly states that test instruments and their accessories must be rated for the environment where they will be used. If you're working in areas that require personal protective equipment, you are probably in a CAT 3 or CAT 4 environment. You should be using test equipment rated 600 or 1000 volt Cat 3 or 600 volt Cat 4.